Welcome back to the stream. Anybody tuning in? I feel bad for not streaming as much as I kind of want to lately. I think mostly I've just been in kind of a foul mood and have been kind of antisocial. Usually I have enough social ability to deal with internet social, but sometimes I don't even want that. Tuco's usually in a fine mood though. Cat. Yeah, Tuco's been super relaxed lately. He's got some good places to hang out, and he likes the warm weather, I think. It's been pretty warm here. It tends to at least have a nice daily cycle, like it at least cools off nice once the sun goes down. But he seems to like the hot weather. For some reason, I guess Alfie is asking if there's going to be any rust. I hadn't planned on working on any rust on this stream. Yeah, no, I just have 3D printed parts and some soldering. Like I said, I'm in kind of a bad mood, so maybe I won't talk as much as I usually do. Alright. Well, maybe we'll first go back to the CAD model and I can show you, because I think the main thing that I've done off camera since the last stream is a bunch of CAD modeling to try to put together a prototype for this next Winch bot design. So that's interesting. I think this printer might have had some kind of offset for like the very first layer when it printed the brim, but most of this model looks fine. It's just like the very bottom of the model seems like it's gone a little bit weird. Anyway, I printed a test for a brand new design for the spool and the way it attaches to the motor, because you might have seen that if you caught the stream a while ago when I was testing the winch, but the first design for the winch failed pretty abysmally due to a bunch of things that I just totally failed to take into account in the design. So I learned from that mistake, and now we have another winch design to try out once it finishes printing. So let's go to the CAD computer. Let's get a little more space. Yeah, I was wondering what Jarrett was asking. Is rust poisonous to you? I mean, it's funny, like if, you know, rust isn't an especially strong thing. It's like weird to choose an oxide like that as a name, but it is kind of catchy. And I enjoy it so far. I'm still new at it, and I am still wrapping my head around the subtleties of the implications of its type system on the complex ecosystem of libraries that are now available. But yeah, it's been fun. Let's see. I was cleaning the gook off my desk, whereas really I should be showing you what's going on the screen here. Find the right combination of devices to operate this computer. Here's the mouse. All right, let's go back, and so this is the thing that we're building. Well, I was going to say right now, but it's not quite right now because I've still got to wait for most of these parts to finish printing. But I have some of them, so we can take a look at what I have so far. And this was the section view, so I was kind of cutting it in half to show the relevant parts. But this is a pretty simple combination of a spool, the existing gear motors I have, and this frame piece that holds it all together. And there's some bearings in there. And a big part of what this is testing is the power transmission between the spool and the motor. And this is all mostly to overcome the problem that I had with the first design, which was largely related to how the spool and the motor were attached. So this is what I had before. Much simpler design. Do we have a section analysis for this one? Yeah. So this is the much simpler design that we had before that broke terribly. So cord goes around the spool, it's directly mounted to the motor shaft with a set screw, and then my plan here was that most of the actual force of kind of tugging on this cable that's on the winch would end up being transmitted through this bearing to the end of a bolt here, which was cantilevered onto a pretty sturdy support on this side. But there were a number of reasons why this didn't really work out. The support on the other side just wasn't sturdy enough because that was built into part of the thin plastic shell around the winch, not part of a proper load-bearing core. The forces inside the spool just tended to kind of want to break apart this glue joint, which was bad. And then I didn't use nearly as strong enough glue. I ended up just using super glue, which I'd had reasonably good experience with in PLA, but it just didn't have a nice flat thing against like a really flat on flat joint, which is what super glue really needs. So I should have used a more viscous epoxy for this. That would have worked out better. So it was a combination of bad design and bad implementation here. And then the other problem was just that these motor shafts, at first I had a pretty serious problem because one of the motors actually had a bent shaft, which I think must have occurred during transit. But of course, because the shaft was bent, it caused this entire thing to just wobble back and forth. But then even without the shaft being bent, getting this set screw to actually anchor on there perfectly straight was really hard, and that was the source of some of the remaining wobble. So what ends up happening is a combination of the stresses from the cord in the winch here and from this kind of badly coupled motor joint here end up just kind of tearing apart the center of the spool, which is what happened. So I could think of a handful of small incremental ways to improve the individual problems with this, but really I just needed to step back and think about the design a little bit differently. And I'd been planning, well, really I was trying to decide between a kind of more direct drive approach where I take basically this design but fix the fundamental structural problems with it and introduce a flexible coupler between the motor shaft and the spool mount. And then separately I was thinking, well, if I'm going to do that, I could solve that with like a gear or a belt drive, and it might actually be handy to have a little bit more gear reduction. Since, obviously to change the gear ratio, I'm already using a geared motor. I could just buy different gearboxes, but I already have these motors, and it seemed like actually having an additional 2-to-1 gear down might actually be handy, both to improve the, the power, the amount of torque I can get with the available power supplies, and just that might actually help with the whole problem of mounting this if I had the ability to get the motor off of the center line of the spools here. So, gears seemed like an easy solution for that, but I was worried that the gears might be loud. So a belt drive seemed like an obvious alternative. My inclination was to try something that was kind of a compromise between, like a fully 3D printed gear and more of a belt drive. And I wanted to try 3D printed herringbone gears, but using a soft material as the outer gear surface and then having a hard plastic core. So that's what this next design does. And, I don't know if it's going to end up being the optimal thing, but it seemed like worth a try. So that's what this is the experiment for. So same motor. The spool is similar. It's a little bit smaller since I think I can get away with that. This time the spool width was a little bit constrained by some of the parts I had handy. Like I already had these M8 threaded sections that were 100 millimeters long. And if we look at the center of this, so this is in a frame that's held together by 2 of those M8 threaded rods. Then there's another M8 threaded rod in the center, which acts to hold the center of the spool. And so this rod is actually spinning with the spool, and it's held, it's held into these supports via these 608 bearings. Whole thing's compressed together with nuts, which this means that the nuts here and the threaded rod are helping to take pretty much all the forces that ended up totally destroying the last spool. And then this is kind of like a bicycle spoke design, giving a surface for the cord to ride on that's a little bit larger diameter, just to increase the minimum diameter that the cord is wrapped around. Keeping the ratio between the minimum and the maximum diameter limited helps the design. And then the actual power transmission works via this gear and then that gear, and then there's a set of press fit teeth that actually transmit power from the piece that has both the side of the spool and this first gear that transmits power into the actual core here. That might be a little easier to see if I turn on and off these individual pieces. So let's turn off the motor. Now we just have the motor mount. And then we can turn off, say, the housing. And we can turn off the hardware. And then this piece on the back is pretty much just like a solid circular plate, pretty thin with a little bit of reinforcement in the middle. So that one is pretty uninteresting. We can turn that one off. And then we have the core here. There's a spot to anchor the cord, and then there's support around this. I ended up modeling this rather than just going with the default infill so that I could have the slicer actually make the plastic around the outside and the center like really solid, but then not as solid here, and then I could control the actual support pattern a little better. And if we look at just that piece actually, like, let's temporarily turn off the other stuff. So this actually, this geometry isn't really supposed to be there. I didn't notice that before. Looks like there's a fillet there that filleted too many things. Yeah, let's fix this. Sorry, I noticed a problem right as I was just trying to explain this. That's better. I haven't actually printed this piece yet, but I'll need to remember to reslice it if that problem made it into the STL. Yeah, so what happened there is, I guess, when I had originally designed this, the fillet hadn't encompassed this part of the part, but something changed, and it didn't update the fillet, and it spilled over and caused some like gnarly geometry that would have led to some sharpness there that I probably would have had to file off or something. I guess we might as well go through the motions to make that G-code now, so that I don't forget. This is the gear spool center. This was the last one I sliced. This one was set up to print pretty much entirely solid. This is basically the pinion, but instead of being a gear itself, it has this surface that's designed to grip the actual gear, which is printed out of NinjaFlex. We'll get to that in a bit. So, gear spool center. That's not the right orientation. Oops. Didn't mean to click lay flat. Now I did. Randomize its bed position a little bit. I don't like wearing out the very center of my print bed. And then I thought that's probably fine. I had the settings here to give me an effectively solid part by setting the shell thickness to 10 millimeters. Let's see if that gives me basically what I want. Let's turn off support materials, since I think this is going to be self-supporting. But let's look and make sure that actually is going to be the case. This doesn't need to be a super clean hole, but it needs to be fairly structural. So this will come up like that. And that's going to be the part where it would start to have trouble. So like, we've got this edge here, which should be fine. Where does it start bridging? So like, this is going to be a little messy because this is going to have trouble printing this overhang, but I think structurally it's going to be fine. And I think it's going to be really annoying to clean out support material from that hole if I print that with support. So that looks good, and then it comes up here. And then those are also pretty much solid, which is good. Okay, these settings seem fine. Let's replace the file that's on the printer. Let's see how the printer's doing. So this is currently printing that kind of outer housing that'll hold this test together. I think this piece, unfortunately, is going to be single use even if the design ends up working, because it doesn't include any mounting to attach it to anything else. I tried to think ahead and try to design some of that, but I think a lot of it depends on the actual center of gravity that this ends up having, which I think I'm going to have to measure after this is assembled. Since, yeah, I wasn't sure how to measure the center of gravity of this thing that doesn't exist yet, given all the different materials involved. But thank goodness for prototyping. Oh yeah, I mean, and as James mentions in the chat, a drill will clean out the hole pretty well if it's got boogers in it, which is quite true. So, okay, back to this tour of what we've got so far, I guess. So we just resliced that. This is the kind of main load-bearing middle of the spool. And then that attaches via this kind of little gear-like joint to this top part, which has another kind of spline here that interfaces to the actual gear. And then the actual gears are these little buggers. Yeah. So these are just the gears. These are printed in NinjaFlex right now, although I might try experimenting with other materials like SemiFlex if NinjaFlex turns out to be too soft. But the goal of the experiment is just to see if this might act kind of like a belt and provide power transmission without the noise. And so these gears were kind of a pain to generate. What I ended up doing for that, I ended up using one of the online gear generators. It was this one by Dr. Rainer Hesmer. And this one seemed like the most mathematically complete generator of the ones that are just online and easy to use. And put in the parameters I wanted, and then generated a DXF. And of course, I tried importing the DXF into Autodesk, and it just couldn't import the file. But if I round trip it through something else like Rhino and then save it to DXF and then import it into Autodesk, it works out. So that's what I ended up doing. And then I had trouble actually doing the twist operation the way I needed to generate these proper helical gears in Fusion 360, and after a lot of frustration trying to do that in Fusion, I ended up giving up on that too and ended up generating the helical gears entirely using that web generator and then Rhino, and then exported that into Fusion 360 as like a step file. So, but that seems to work all right. And then I did the rest of these features in Fusion 360, like these internal splines are all in 360. So that attaches there. And then we have this other piece that I've been calling the drive core. It's like a little pinion that fits onto the motor. That's pretty much it. And that goes on the motor shaft. I thought about using a set screw there, but I wasn't sure if the set screw actually did more good than harm. So I figured I'd try just printing a tight press fit out of really solid PLA there and see how far that gets me. One thing that will hopefully help is that this herringbone gear design tends to be self-centering. So this part is designed so that the flexible part of the gear will stay centered on the plastic. There's like a lip on top here, which you might be able to see if I turn that off. So that'll keep the rubber part, the flexible TPE part, centered. And then there's a little room for these to wiggle around, but hopefully they don't move too much. I might end up needing to add some kind of locking compound or glue or something if they do, but we'll see. This is a test. So, and cat. So I've got some of these. These are the Ninja Flex gears, all flexy and delicious. I printed these with, I want to say 0.1 millimeter layer height. So this one has some cobwebs in the center I haven't cleaned up yet, but that doesn't really matter especially much since that's just going to end up getting squished onto the PLA anyway. The outer surface is pretty nice. And I already tried putting on this one. I can try doing another fit here, just for video's sake. So these, you know, they can slide off, but it's going to take some pressure. I didn't actually allow any clearance in the CAD model here, so I assume that because of the, you know, print boogers and other tolerance issues, that it has to flex a little bit, which is where some of the friction's coming from, which is kind of intentional. You know, I don't want that to be like super deformed from the shape I want it to be in, but the pressure is nice, and I think it's got a pretty good balance at this point. What was that? Is that the HDMI cable having issues? Yeah, you can kind of see the weird concentric infill pattern I ended up using. All the layers are just like that, solid all the way through. And then this thing is basically a Lego tire. You do have to be careful about which way you put these on, since, I mean, these are reversible, so you'd have to just swap the other end, but I want to be consistent with the CAD model, so I'm going to double check that. Yeah, so according to the CAD model, it goes together with that chirality. It's also possible to put it together that way, but because these are herringbone gears, you know, they only mesh in one direction. They aren't actually symmetric. So that meshes and kind of self-centers, but if you rotate this the other way around, then you also have to rotate this one. So I think that's the right orientation. And carefully squidge this on, a lot like putting on a Lego tire. that pushes all the way up until it hits that ridge. All right. So this is the next piece. This needs a little bit of cleanup. This is pretty much fresh off the printer. This printed just right before I started this pretty much. And I took off some of the brim, but it needs a little more brim cleanup. There's some cobwebs in here too. Oh, this knife is really sharp. This is a pretty new blade. Oh, speaking of things that'll be fun to do with a sharp knife, I got some mail recently. This is to my shop P.O. box from Andrew Zunenberg, who sent a hardware hacking challenge. It's a PCB rework capture the flag board. So I think I want to do that when I'm in less of a foul mood. I think right now I just want to do something simple that won't frustrate me additionally. But that should be super fun. And you might have seen on the previous stream I got some DigiKey parts that go with that board. So I printed this completely solid. Well, actually no, it's not completely solid, I lied. The pinion here is completely solid. But this was not solid, it was just at much higher than my usual infill. So not totally solid, but close. And I think that affected the surface finish quite a lot. There's some over extrusion happening, so on each layer there's kind of more plastic down than the slicer was really expecting, and then the nozzle kind of drags on the plastic that's already there. And the way my printer is designed, that tends to cause the whole print bed to move, because the print bed is only kind of loosely held down with some bolt heads. So I ended up kind of working around that with some additional tape. It's a little bit of a contraption. But aside from the gnarly surface finish, I think this part came out pretty well. And it should be pretty strong. And it should be easy to make more of them if this design works. So I'll be interested to see how these soft gears end up working. There's plenty of alternatives if they don't. I could use, I could compromise and use semi-flex instead of ninja flex and see how that works. I've seen a few people suggest using, using like actually manufactured drive belts, but then actually basically making a 3D printed housing that turns them into kind of a gear. And lots of 3D printer designs use drive belts and timing belts in interesting ways. So a belt design is certainly on the table still, but I wanted to try this to see if it would work. And I started to try to design something with a belt, and I think it's going to be easier for a gear-driven design to be smaller than a belt-driven design, but it's probably possible to make a belt design that's about as compact. So that might just require some more thinking about it in CAD. Oh man, this is the kind of stream where all of you can just like cheer for blood from the stands. Weird. It looks like there was the build plate shifted while it was printing the brim, because the brim is slightly offset from the rest of the model. It doesn't seem like it caused it to warp at all, which I'm lucky about. But I do need to make sure these slots are properly clear, or this is not going to fit onto the hub. Man, so much to go wrong in 3D printing. But it's fun, and often useful. Maybe obsessing over this slightly more than I need to, but I just, like when the profile on the bottom that I'm seeing here does not look, well, I was going to say like a rectangle, but these are not actually rectangles. These are like arc sections or something. But when they don't have nice corners, I don't think the next part's going to fit well, so. And that part isn't even printed yet, but, you know, gotta plan ahead. I'm just getting into each of the corners and trying to sharpen the corners. I could make this a little easier in the design by incorporating like little relief circles into the bottom couple layers of these holes. There is just an overall clearance around the little drive pegs of, I made it relatively small, I think something like 0.1 or 0.2 millimeters. You know, small for 3D printed parts. So it'll probably still be kind of a tight fit, but should be possible without breaking anything, I hope. And I'll also want to do that fitting with the M8 shaft going through here probably, because otherwise I would worry about it going in at a bad angle. I think I want to use that shaft as the clamping force to put everything together. So I can just put a threaded rod through there and then tighten nuts down on either side. I think this needs to be a relaxing stream. Like, man, I get so stressed out by people most of the time, but this can just be repetitive 3D print cleanup and soldering tasks, basically. Hopefully a little meditative. Hopefully you don't mind the scraping noises, because they're probably going to continue. See if I can get in a little closer. Gotta change up the camera angle, or otherwise the footage just ends up being kind of monotonous and I don't have as much to edit with. I've been going through some of the YouTube videos from the Chemical Safety Board, which is, man, it's really amazing the scale of industrial accidents that it takes for us to learn safe process on a large scale. It's also just amazing how much danger is inherent in stuff that we all just completely take for granted, and then how much humans freak out about dangers that are so relatively, you know, relatively invisible, or not even invisible, but just completely unlikely. You know, you worry about planes crashing and stuff instead of crashing your car, that sort of thing. I would like to not have to do this for all of the winches. I mean, it's not a big deal because there's only 4 of them, but I think fixing whatever issue caused the brim to be offset would be nice. It's also, it would be nice if there was a way to have the brim only print around the outside edges, because it's really not necessary on these inside holes and it's just annoying. Whereas if I turned it off on the outside of the part, I would actually worry about warping. Brim is really playing a large part in holding it down with the print bed, since that printer doesn't have a heated bed. This part might actually be small enough to fit on my printer that does have a heated bed, but that printer is also not as accurate. So all the motion control related parts, it would be nice to print on my printer that's larger and more accurate, even though it doesn't have the heated bed. I totally have the option of gluing these pieces together, but I don't know if that'll be necessary. Between these little fingers, and I probably will put some Loctite or something on the nut, because I could see that coming apart and being a problem. And it'll be vibrating and spinning and all that. But these plastic pieces might not need any adhesive. Okay, I think that's the middle. Let's find an appropriate drill to clean that out. Thought I had my drill bits right here. 8mm is pretty close to 1/4 inch, right? 1/4 inch is a little smaller. 5/16 was working before for the carbon rods. I don't know if this will be on the big side here. How does this drill bit compare to the size of my bearings? I should guess is the question I should be asking. And my threaded rod. So here's the bearing, here's the rod. That rod definitely needs some more space. The drill bit is maybe on the big side. I don't know. It's pretty close. Maybe we'll actually try that. It's definitely the closest drill bit I'm gonna have here. And it worked pretty well for the carbon rod. Oh yeah, James is confirming that 8/16 or 5/16 and 8mm are pretty close to the same. All right, let's try this. could take this over to the drill press, but I think this will be sufficient. That is really catching. Maybe I just want to turn this by hand. Is this working out all right? Seems to be. I mean, I'm a little worried about the centeredness of that, but I think it's guiding the drill all right. Let's actually lock this. Mikkel suggests using a pair of scissors as a tapered reamer. That would be nice if I wanted a tapered reamer right now. I might use that for some of the other holes. Okay, I think that got what I wanted. Get out of there. Big old chunks of red PLA. Oh, that makes me happy. Yeah, I think that'll do. Okay. I want to clean up this edge, and then I'm going to put the gear surface on here. I think that's about as far as we can go on this sub-assembly until the other 3D print finishes. The next piece I'm printing is the enclosure. So instead of printing the other half of the spool, I wanted to try printing the mount that would let me actually drive the two gears together. But then the next piece I'm printing is probably going to be the core that plugs into these holes. Yeah, surface finish is a little gnarly on here because of the over extrusion. But it looks strong. I didn't do that and get it on camera. What is that saying? Cut toward your knuckle, not your thumb. Is that not how it goes? I could see this going much smoother if I had just the right speed, really slowed down sanding wheel maybe. I think my sanding wheel at its regular speed would just melt this plastic, but maybe if I put it on a speed controller. There's some little bits of brim here. Clearly I should just do this on the motor. Just stick this in the housing, hold the knife up to it, turn on the power. I mean, that might work. I don't know if I left enough clearance for the entire brim once the whole thing's assembled. I just put the middle of the whole spindle in the drill chuck. Actually, yeah, those threaded rods go just fine on a drill chuck. Oh, my chum. That's what I was forgetting. Does that mean Tuco? Because that seems kind of mean. Man, this surface finish is pretty gnarly. But... Alright, I think that'll do. This part of the spool is a little light. I think this is only like 1 millimeter thick. But should be alright. The part that needs to be strong is hopefully strong. The rest of this is just to keep the cord from falling off. So then, let's make sure I'm putting this on the right way, so that will not mesh. This will mesh. And so that fits into these little squishy holes. Let's maybe try to clear these all out first. I don't know if I had to do that on the other gear. I mean, these mostly look fine. I might just need to press. Oh, some of these have slight cobweb blockages. Let's try that. Try not to stretch it too much because you can actually deform this stuff by stretching it, but it should stretch enough to get over this lip pretty easily, I hope. And then hopefully I can get this fully seated and the little groove it's supposed to sit in. Just pressing down each of these little spline gear things, little nubs that hold this together. All right, that's my Lego tire. this rough surface might actually be a problem if it scrapes against the edge of that gear. That might end up wanting more clearance, but there's only like 1 millimeter of clearance there, which is probably not enough. Yeah, this is, I mean, I can clean this up if I need to. I don't know if I need to. Alright, I think this can wait until I have more of the parts printed, but it's doing alright so far. Oh, Mikkel asks if we can see the CAD model. Of course. So, turn on all of these parts. So that's the CAD for my test spool. So it doesn't have any of the parts it needs to be a real winch bot, like the sensors or the electronics. It's just a motor mount and some gears. Hopefully, if this works, I can reuse the spool and gears, but I would have to replace at least one of these two mount halves with something that includes additional, mounts for other stuff. But this will be an experiment. It'll tell me what's wrong with the design. So if I take off the housing, maybe you get a sense for what we're dealing with here. So those are the flexible gears. These are the pieces we've got right now. Bearings, threaded shaft. And this just press fits onto the motor, so it's free to move up and down a little bit. Not really up, as you can see. Not very much room there. So that's what we've got for the winch. This was the old design, where the spool was attached directly to the motor. This one didn't really work. Then, I mean, there's also all of this other stuff, which is going to need significant redesign. And this was the way the spool and the motor and all the electronics and sensors and everything could get packed together. And there's a whole plastic shell around that, printed in 2 parts, and a wall mount that I hadn't designed yet, and a whole complicated thing. This is the thing that's partially assembled in the shop behind me. Maybe you can't see it. But I was testing that a few streams ago. Okay, so let's put that aside for a little bit, because we could use some more printing. That piece is still printing away. This is the 2 halves of that kind of frame that we'll need to test this next piece. Looks like there's a decent amount of solidity in that left part of the model. I guess it's printing the first couple of layers of that solid part. Anyway, cat's having a good time. So, let's switch gears, and go back to the flying robot. Which doesn't have any gears. No gears in the flyer. Okay, this one is just all one CAD model at this point. So I've been through this a few times in the past. It hasn't really changed a lot lately. I'm just assembling it. I've got these parts. We went through the process of discovering how to assemble one of these LED ring modules on the last stream. I still need to assemble the other two, and just generally assemble a bunch of this stuff onto the carbon fiber frame. I think maybe the thing to do next is to try assembling this top piece, which we hadn't really tried last time. I think that might be nice to do. So let's try doing that next. That's just this one piece printed out of, well, this time I printed it out of carbon fiber PLA because that's what I had handy. It's kind of a weird material, but I was about out of regular black PLA and I wanted it to match the color of the other parts. But you could print it out of whatever. It's a pretty thin piece that mostly holds LEDs and provides an aesthetic cover to the wiring mess that's going to be under here. So, oh yeah, this is also something we will get to later, but I'm going to try lubricating these gears. I've used this white lithium grease in the past, like for 3D printer lubrication and such. I've also used graphite lubricant, although it's probably not the right stuff for these materials. For 3D printed stuff, I've heard people recommend this stuff, this super lube, or generally like a silicone lubrication, so I thought I'd try this. Silicone gearbox lube. See how well it works with the flexible materials. Heat up this glue gun we've been using. Well, actually, no. We'll need that for doing the LED rings, but for the top, we probably don't need that yet. So here's one of the rings we built before. Good old little sandwich with LEDs and hot glue and plastic. So we can build a couple more of those. And this is the piece that's a little weirder. It's got places for LED strips to poke out. So these fit in kind of like that. And this will need some wiring directly on the back side. So I haven't entirely figured out how I'm doing this part. I think it might involve taping the LED strips into place and then wiring them with really thin wire, possibly magnet wire on this side, and then putting some more permanent adhesive down, like maybe a thin layer of epoxy after I do the wiring, after I test the LEDs, with the tape holding it into place, and then after the epoxy cures, take off the tape. I think that might be how it goes. Let's find out. One constraint is this whole thing needed to be somewhat thin because I'm putting it right under this other piece, which I didn't have to do it that way, but I thought it would be a convenient way to hide the wiring on the back side of the LEDs since there'd be another piece right behind it. Maybe convenient is not quite the right description for that, but that's how I was thinking about it. So then this. Such an amorphous barrier, like the boundary between stuff that is actually stuck down and stuff that is not stuck down at all is pretty fuzzy. So this was, I mean, it's all the usual support material stuff where you're printing right on top of support, but I also had a brief extruder jam. Well, not really an extruder jam, but filament tangle, I guess. This filament is very stiff. And it's the carbon fiber loaded PLA, because it was the black filament that I had on hand. And the first time I tried printing with it, and it's interesting stuff. It's pretty stiff, and not like I'm sure it's like structurally amazing or anything, but the filament itself is pretty rigid, and that caused it to actually jump off of the drive gear while it was printing. And then I came into the closet and noticed it not printing right, and so I fixed it, but I wasn't really sure how long it had been not working for, so I watched it print the rest of the layer, and it turns out I got really lucky. It was just missing some of the interior parts of a layer where they would, like, there was plenty of redundancy. That part of the model would be really well supported by everything else. It shouldn't cause any visible holes, but that might contribute to some of the badness under here. It meant that some of this stuff printed on top of less support than it would otherwise have had. I think the bad layer was above the layer of this support material proper, but I think it was in one of the first couple of infill layers that provide this flat surface that I'm scraping against right now. So part of that surface was not as well formed as it could have been. Oh, humans. Humans are so weird. Some of those might be done better with a knife. Trying to clear out the areas right around the LEDs and the LED strips especially. This doesn't have to be perfect, but I don't want anything that keeps the LED strip from really sitting down in there. This would have been much easier to print if it was the other way around, but the whole top of this is curved, and I think that was important for keeping it looking thinner than it actually is. I think seeing a really thick edge on here would have, I don't know. I like the curve. I guess I was willing to put up with all of the support material to get that curve. This material it feels somewhat brittle. That's one set cleaned out. I think that looks all right. Let's see how the strip fits in there. Let's decide that they should all be facing outward, maybe. Oh, I think that works out. So I could fix this down with a little bit of Kapton tape. So I designed this with maybe tighter tolerances than I should have, but there should be an entire, couple of tenths of a millimeter of room above the LED strip. And so there's plenty of room for some magnet wire or something to attach there. I'm just thinking about how to hold this down really snug while I'm working on it. Because if I just tape this down, it's not actually going to press it completely down into the channel. So it's like I want something with little foam pieces that presses on it. Maybe I just have to press it down with my fingers. I mean, if I'm using 5-minute epoxy, then putting a little epoxy on the surround of the circuit board and then just pressing it down with my fingers is probably fine. And maybe I just want to do that before doing the wiring. Otherwise, otherwise I don't know how I'm going to get this to seat all the way in there. That's going to be really annoying if I have to replace these LEDs, but what I probably have to do then is just pry out the circuit board, sacrifice the circuit board, clean off the plastic, put in a new chunk of LED strip to replace the one that I need to replace. That seems annoying, but not like a huge problem. Okay, well let's get these others to a similar level of cleanliness, and then maybe we mix up some epoxy. Those little bits of LED strip are cut from a larger strip that I've already tested. I mean, it would be ideal to test them all beforehand, but I think maybe tacking them down in here and then just doing the wiring might be the way to do it. Mikkel says, what about hot snot? Oh, I guess that's a good question. Would I trust it to hold that small bit of stuff? I guess the way I was imagining using the epoxy is basically putting epoxy on this surface that's exposed here, just those two edges. Maybe point with something smaller. So like this edge, and then pressing the circuit board down onto there, and then keeping pressure on it until the epoxy kind of sets. Sounds kind of annoying, but don't really know how else to do that. With hot glue, I couldn't do it that way. I could put the whole thing down and then put a bead of hot glue up here and then a bead down there. But for that to work, I would basically just be relying on that tiny, tiny crack because I don't really want the bead to go above that level very much. So I think mostly it just boils down to the surface not really being accessible enough to use hot glue in this case. But that's a good question. I think I need some glue that takes a little bit more time to set than hot glue because it's in a surface I can't directly apply it to. Another option might be to use spray adhesive or something along those lines. I think that's going to have trouble bonding to the weird surface of this PLA that's printed on the support material though. I think if it was just LED strip against something else, then using, say, double-sided tape cut into just the right pattern might be a viable option, but in this case, I think epoxy's probably going to help. Yeah, some kind of like thick, goopy sort of goo, so epoxy, or like if it wasn't for the geometry problem, hot glue would have worked pretty nicely. I could have made it easier to apply hot glue by giving myself more room at the edges here. Maybe little cutouts to hold the glue, but I didn't design it that way. I figured I would either be using tape or epoxy. I hadn't thought about making it accessible to hot glue at the time. I mean, I could try a tape. The other option is tape, but put something thick on the back of the LED strip that's temporary to put pressure on the back of the tape. Such weird support material with fine waffle layer. And it is a little sharp. Mikkel says the hot snot could melt into the plastic. That definitely depends on how you apply it. You certainly can choose to melt it into the plastic and make a really sturdy bond that way. You can also apply it a little bit colder. got this like 100-watt Surebonder hot glue gun, which is amazing, and that's the one well, sometimes I'll put the black hot glue sticks in it. Lately I've been using them with this one because I got the thin kind, and so I've got these really tiny hot glue guns that work with them. But yeah, when I'm using that glue gun, it puts out the glue at a fairly elevated temperature, and so it bonds really, really, really too well to plastic a lot of the time. But it's quite good if you want a bond. Oh, Mikkel is asking which slicer. I used Kira. Ow. Very sharp. Sharp plastic stroopwafels. Yes. Oh man, stroopwafels sure are tasty. I think I first learned about stroopwafels when I was strictly vegan, so I hadn't tried one for a long time. And I finally got to try them and see what all the fuss was about when I was in a more vegetarian place later on. Yeah, this plastic is a little bit irritating. Oh, another wonderfully exciting task we can do on the stream. On many people's recommendation, but especially Ken Keeter, who sent me the specific link for the stuff I ended up getting, I got some less crinkly tubing to put the leash for this robot in. So instead of that kind of, made from recycled garbage bags split loom tubing, it's more like the kind of woven expandable stuff that is kind of like a finger trap, but for tubing, and it's super long. So, putting that on might be a little annoying, but I figured we could share the pain. Like I said, I'm in a great mood about humanity right now. But you know what? Cats are pretty amazing. Dogs are great too. I like dogs. I have more personal experience with cats, but I've certainly had interactions with amazing dogs. And Tuco's a bit dog-like as far as cats go, what with his constant desire for attention and to play fetch. Oh, was somebody asking to see the braid on the stream? Yeah, we can do that. I already tried a test fit just to see how it would go, so part of it's on the wiring, but it's still mostly on the spool. I think some of these little boogers will be pushed out of the way by the actual LED diodes, but I could also see them really easily just obscuring the LEDs. And this is also not the most important feature. I mean, it's mostly intended, I think, for kind of a mini-map view that'll have an overhead camera, which isn't even something I've really done much design work for yet, but I just wanted support for it in the robot so that we could add that to the actual stream once the rest of the pieces were available. I think that'll mostly just be, I have a Raspberry Pi up on the lofting, or up on the loft railing, connected to the same network as all the flyer robots, and it could just have a Raspberry Pi camera maybe. And then I could also connect that to, I've got a thermal camera earmarked for the same task, so it'd be nice to have a combination of visible and thermal. Oh, that feels like it fits pretty nicely. Definitely won't hold itself down, but if I actually press it in there, then it looks like that on the other side. I like it. Man, Mikkel was saying that they would already be done removing with like 10 cuts. I've been shy about this stuff because it is actually really sharp. It's like regular PLA can be kind of vicious sometimes, but this carbon fiber enriched PLA is even sharper and more annoying. Also trying not to break my model too much, but it seemed like the model is stronger than my hands. Like, the slicer seems like it did an alright job of separating the support material from the parts I want to keep, for the most part. I can probably get less shy about scraping this. Although maybe I want safety glasses. Maybe I want a hard hat. Maybe I want a traffic cone. Maybe I want a spinning, blinking caution light. Or dissolvable support material. Oh man, support material. So I briefly ran a shop on 3D hubs where, you know, you can just have someone in your area print a 3D model for you. And while I say briefly, I mean, I didn't actually shut it down intentionally. It was more that they shut my shop down because of the volume wasn't high enough, I guess. I guess they were tired of having shops that didn't look very active. And so they were just like, you're not a high volume shop, so you don't get to exist, bye. So I was like, okay, whatever. Because it hadn't been like an especially great experience, I think, for anybody the last time it happened. Like, I had a couple of orders. Somebody ordered some really complicated parts that required tons of custom support material, and I spent all this time like 3D modeling custom support material for this person, and barely got to charge anything for it. And then I think the person was kind of dissatisfied with the result because, like, well, dude, you asked for these really complicated parts on an FDM printer. What did you expect? I did my best. So, and I don't know. that's kind of my experience with 3D hubs. Like, I feel like I can get pretty good results out of my printers because I know what they're good at and what they're not good at. But communicating that to a third party is maybe harder. Or maybe this was just not a great customer, but, you know. And it was just something I set up because it was easy and I didn't spend a lot of time like marketing it or whatever, so I didn't get a lot of traffic. It's weird that 3D hubs, like their response, oh, this store isn't getting much traffic, instead of driving more traffic to them, you shut them down. It seems like a positive feedback loop in the making. Oh, the sharpness continues. Removing support material around these little delicate things in between LEDs, I think, is the trickiest part of this, because I know that those pieces are relatively fragile. I don't want to just take one out with the screwdriver, because that would be really easy to do. Oh, that's an interesting suggestion, using tape as a barrier between the print and its support. I hadn't heard of that one before. I guess you really have to design for that and make sure that the barrier between the two pieces is something that you can cover manually, but if you can do that, it sounds like a really powerful technique. I might have to try that. I don't really have a good workflow for doing like weird G-code things like that, like splitting up a print into parts that need manual steps in between, so I'd probably have to post-process them a little bit myself too. I know there are slicers that can do stuff like that without external tools. Like, I know people have recommended Simplify 3D before, but I tried Simplify 3D a while ago and found it kind of frustrating because whereas I had all these really nicely dialed in profiles for Kira already, I would have to pretty much entirely start from scratch with Simplify 3D, which wasn't worth it. think Mikkel is suggesting manually editing the G code, which I know is something you can do, but that's hardly a workflow. I don't know, I'm kind of a stickler for having a process to reproduce things whenever I can. So, I mean, even if you could do it manually, I'd probably just write a little script for it. Yeah, pretty much everything about this carbon fiber PLA is weird. It even comes on a weird spool. I don't know if they still do this, but Protopasta had this cardboard spool design they were doing when they shipped this particular roll to me. And I got this a while ago, and it stayed sealed in my printing closet for a while, and I recently opened it to make this print. And partly, I recently upgraded the nozzle in my printer to a tungsten carbide nozzle, which is supposed to be longer lasting in general, but also especially longer lasting when you deal with abrasive filaments. So it seemed like a good way to break in my new nozzle with some of this stuff, since I already had the necessary components. And the whole thing about this being the only black filament I had left when I wanted to make this match the sensors. Alright, let's see if that fits. Alright, one more of these to clean out, and we can do some wiring and epoxying in some kind of order. Maybe we can do some epoxying and then put on the cable snake while we're waiting for the epoxy to cure. I'd like something I can use to weight down these LED strips, maybe. I think if there's something I can use that's somewhat massive, but only in a small area like this. I also might be able to find little pieces of foam that I could put on top of the LED strip just while the glue is curing, and then tape the foam down to put some pressure on the LEDs. Whoa, 71 people watching right now on YouTube. Hello, everyone. We might have some folks who haven't been following this project, so in case you're curious what this is for, this is one of many 3D printed pieces for this little robot that I've been building recently, which is intended to let folks on the internet interact with my cat and potentially other animals like myself in the space. It's basically a little hovering camera with a gimbal, and it runs on 4 nylon cords that are each connected to little winch robots. And so this piece is the very top of the robot. Just a thin plate. It'll have some LEDs mounted in it, which are what these holes are for. And the LEDs, partly for fun and partly for navigational purposes. I don't really know entirely how I'm going to use them or how I'm going to divide the, like how much of this is for navigation and how much of it is for just for fun, but these will be pointing upward toward a camera just kind of above where the robot usually hangs out, and you'll be able to see them in kind of a mini map. And I'll probably do some computer vision to find the robot using these LEDs. But it might just end up being fun. I might end up having other location mechanisms, we'll see. So it's kind of a plan for a few different eventualities. And these addressable LEDs are just pretty easy to stick wherever you want and use them in different ways. The addressable LEDs on the bottom are mostly going to be for communicating with humans who are in the area, since they won't really be visible on the stream, I think. Not very much anyway. You'll probably be able to see them from the loft camera, but the intent there is to have a way of communicating, like if the robot's in a particular mode, or like if it's filming you, or if it's like if you're in the way or something. There might be different ways to represent the sensor data on there, and different ways to show the current mode the camera is being controlled in. Well, they're little waffles. You just kind of pull some of these off intact. I'm kind of hoping this robot doesn't get kicked off of Twitch immediately again. I'd been testing just the streaming infrastructure behind it by running a mostly stationary camera of my cat that I would just stream, but it turns out that was against the terms of service. So they kicked my account off for 24 hours, and it's since been restored, but just to play it safe, I was not going to try the stream again until it's actually properly interactive in some way. But it seems like as long as there's some kind of moving camera and some kind of interactivity, I'm hoping that'll be fine, so trying to get to the point where that actually works so I can put the camera back online. I've got pretty much everything I need to finish assembling this actual flying part of the robot. I just need to do the work to actually do that. Its firmware is mostly done. Well, the flyer's firmware is pretty much completely done. The winch firmware is mostly done. It still needs a motion control loop. And then the winch is in the middle of a mechanical redesign right now. So that's still maybe going to be the limiting factor in how soon I can get this project actually working. Man, Tuco seems pretty chill. We should maybe get you a better camera angle to enjoy the fuzzball with. And that's really what this project is trying to head toward, is to make that part easier. We're so close. Seems into that. Oh, Charles was asking what category I was streaming under. Yeah, it was set to IRL, which I know was part of the problem. I think right now, well, I haven't done any broadcasts since the one that got it kicked off, but yeah, I think I'll just have it set to uncategorized or something next time. I don't know. Oh yeah, Skyforge. Yeah, I don't have good memories of that slicer. It's so slow and just does inscrutable things with your geometry sometimes. But mostly the part where it's slow. Just noticing a couple of loose threads in there. Okay. Let's clean this off a little bit and then mix up some epoxy. Oh, and I should find some foam. I'm also going to have to be really careful about labeling which electrical connections are which, because it's going to get really hard to check as soon as I epoxy these down. Oh my god, this trash can smells like cat food. Why? Ah, what a mess. So, don't know what that is coming from outside, some kind of squeaking. Okay, let's open up a new file in DaveCAD and make sure we capture this. Alright, so then we have minus, plus. Okay. We can figure out the data lines, but we need to at least make sure that we're very, very clear on which one is plus and which one is minus. Okay, so we'll save that for later. Oh, foam. big enough? Yeah, so we have a flat surface, our flat print, and I want to actually put pressure on the LED strips to press them in all the way. So I was going to cut some little pieces of cardboard from this random box. And maybe some double-sided tape to hold those onto the LED strips. Oh, I was laughing at Brendan's comment that they love the Dave Cat stickies. Yeah, I need to print some more. I should do another pirate print run. I made some with pink ink, which I like a lot. The ones that I tried to do light in black ink, because the really dark black ones are kind of hard to use. The really light black ones are all right, but they're kind of hard to print. But printing with pink ink actually works out really nicely. So let's put this glass aside. Glass aside somewhere safe, maybe. And this is fairly thin cardboard. So I want some strips that are a little bit thinner than the LED strips. Only by a little bit. You know what? I have a paper cutter contraption. I don't know if it can handle... It probably can't handle cardboard, even this thin cardboard. And I'm just trimming this because the cardboard is a little bit squished and I want it to be as square as I can have it. Something like that. Yeah. Something like that indeed. So a few more of those. Let's take the best one of those, best 4 of those rather. Okay, so let's place all these LED strips and tape them to some cardboard strips. That's fine. And we want to make double sure that these are pointing outward, just like our CAD model suggests they should. That little extra tag of tape will just serve to hold it in place a little bit, I guess. So, yeah, I want to get that prepped, but then leave it so I can put epoxy under there. And then I'll put the glass plate on top and flip the whole thing and put some weight on it. Pointing outward, plus and minus in the right places. double-sided tape smells kind of weird when you first unstick it from the roll. I don't know if this cardboard is going to be super even as far as pressure goes, but better than nothing. All right. So we have that. That's pretty much ready for the epoxy. Then I have glass and a sandbag I can use for weight. Borrow the sandbag safely. Okay. I think I'm just missing an epoxy mixing apparatus. So, I was gonna see if maybe using one of these little glue syringes might actually help. Might mix it in here and then try squirting small amounts just along those edges using that little syringe. I don't know how well this is gonna work because this epoxy's gotten a little bit thick. But let's try it out. So there's the hardener. The resin is the stuff that's a little harder to deal with. Yeah, maybe I should not be using 5-minute epoxy for this. Do I have 30-minute epoxy handy? There's also E6000 or Shoe Goo. E6000 might be nice for this because it's a little bit flexible. It's pretty strong. Has better drying time. It would stick really well to the plastic. Yeah, maybe I shouldn't be using 5-minute epoxy on this. That does seem like a problem. Let's try E6000. E6000 will take a while to dry, so I probably won't be able to solder this today, but I can at least glue this all together, put some weight on it, and then work on the cable snake or any of the other pieces behind this. And the E6000 should work fine with the syringe too. Let's see if I can do that. This stuff has some similarities to hot glue, but it's, you know, instead of heat, it's just based on terrible solvents. But it dries to be still pretty flexible, and it's clear, so if it gets on the LEDs, it's not the end of the world. Let's pick a decent amount. I've got plenty of this stuff, and I think the syringe full of it is going to be easier if I have a little puddle here. Delicious. got some bubbles in there. This puddle is actually plenty to fill the entire syringe. I guess I overestimated how much the syringe could hold. Part of the reason I've got a bunch of this is I was doing a project that involved mixing this with broken glass, because the effect is actually pretty cool. And now that anytime I see a puddle of this, it's like, oh, I've got more broken glass I can mix with this. That would be fun. Let's put this where it needs to go. Yeah, this stuff is pretty noxious. I don't know if it's going to be enough to just have a layer of this on the plastic. I'm also pretty sure that this is going to get between the diodes and the edges, but that's probably fine. I'm trying to calibrate how thick a layer to put down. Make sure that there's enough on the top and bottom. Okay, let's try that. Deliciously squishy. Let's put this on something so I'm not pressing them. Some of the diodes are actually contacting the mat the way it was sitting. Okay, let's work quickly. Try not to make a giant mess. One nice thing about E6000 is you can basically just peel off any excess. It just kind of forms this like rubber booger that you can just remove by pulling. It kind of comes off in a big sheet. Getting glue on these little bridges is hard. I wanted to get at least some on there. All right. And it's like I'm a 3D printer managing my own flow rate. Unintentional glob right there at the end, but I think we're fine. Yeah, this is gonna want some clamping pressure really soon. Might suck up a little more glue while I can. Thanks, little puddle. Did I get another air bubble? Maybe I got an air bubble. That sucks. Okay, well, it looks like one syringe full of glue is pretty much barely enough to do this job. At least the way I just did it. Didn't really need to reload it though. Cool. Okay, so all the diodes are roughly in the right place. Let's have the sheet of glass. That seems better. And maybe a piece of, I guess another piece of that same size glass is handy, so this will just, do I want this? I think that might help spread it across the 4 sides at least, and then a sandbag. Let's look at this from the side. All right, not much to see. Anyway, there's that. Oh, Michaela's asking if the LEDs touch the glass. Good question. Maybe they are. It's a little hard to tell. Yeah, you're right. That would have been a problem. Thank you. Well, yeah, maybe I just have to carefully put the sandbag directly on here. The place where it's going to touch the, like the place where the LED pokes up higher than the surround is at the edges, not in the middle. So if I put the weight on the middle, it should be fine. Make sure this is actually distributing the force enough. I mean, the cardboard's still providing some pressure on the back, it looks like. It seems just manually, like if I press it right about here, then it's going to sit the way I want. Better, I think. Can we get a better view of what's going on in there? I think it's holding in the right spots, but let's just double check this. I think this will be fine. Alright, I think we should leave this alone, probably. Just trying to get a better view of the far edge too, but I think we're good. Alright. Oh no, I think my magic arm needs maintenance again. Okay, well, I think there's maybe one more thing we do in this stream. I mean, we could work on some of these LED rings. I've just made that harder with setting this up here. I might move this in a few minutes. But I think right now, let's do some of this cable snake work. So this is my attempt so far at creating a tether for this bot. So I really should open up the magic arm and put the bearing in the right spot, because that's a problem that needs some attention. So this stuff is kind of convenient because, well, I had a bunch of it handy because I use it to cat-proof wires, and it's relatively easy to put on and take off, but as you can hear, it might be a little crinkly when we have this robot moving around. So instead, I ended up getting a spool of this stuff. So this should be about enough. This should be 100 feet. Oh, right. Yeah, braided sleeve. So we'll see if this helps. This was a recommendation from Ken. I think a lot of people had suggested this general kind of material, though. It's a little bit annoying to put on. So you can press it and it expands, and so it will mostly expand over the cabling. It's tempting to cut off the BNC connector here and re-terminate it, but maybe I should avoid that. Let's definitely cut off these wires because these are not helping. Alright, so for this stuff, expand the cabling, or expand the sleeving, and then hopefully just shove it all through, and hopefully that works out. Oh, the servo AF is really not working out too well today. And so I'm still kind of undecided about whether I even want to deal with getting it over this termination, or whether I want to try to just re-terminate the cable. I guess let's just see how far we can get. It seems like that might not be bad, actually. It does seem like I'm just going to have to kind of shift this down across the entire length of the cable, though. Oh yeah, it is kind of like a snake swallowing food, isn't it? Yeah, getting it over the very end of this is a little bit tricky, but I'm hoping the rest of this, it'll just be a matter of kind of massaging the snake. Oh, just noticed a question or a comment from Matt in YouTube chat who says that job would be easier with a real chisel. I imagine they were talking about clearing out the support material. Yeah, I didn't have a super tiny chisel on hand, but maybe that would have been the right tool for the job. Yeah, it is nice that once you get it on the wire, it'll just kind of bunch up and get wider. And then hopefully I can just release some of that stored length from the other end. Yeah, I can imagine it being harder to keep it on actually without at least one connector on the end. So maybe the little BNC might be useful after all. This part's starting to need to move. Cool, we got to the point where, I mean, we can just go ahead and take off all of this. Which luckily is easy. Oh, nice. James is imagining a mechanical device that does that repetitive motion I was just doing, which seems like something right out of Dr. Seuss. So this leash was around 100 feet, which I think was mostly set by the length of the coax cable that I could conveniently get. But it also was about the right distance to hopefully make it all the way down to the server rack after hanging out the ceiling. If I do need to extend it a little bit, then it's pretty easy to do so, but I was hoping to at least have one continuous cable for the part of this that's flying around in the ceiling area. And if I need a different cabling solution for getting the signals back down to ground level, then that's fine. But I think it's going to be long enough. It's getting twisted. Maybe I should start taking this off from the other end also. I mean, I remember this having trouble with being twisted when I first installed it too. This stuff is so nasty. Yeah, it's very twisted now. Oh, and this piece isn't even connected, is it? Oh, this is what I've already taken off. Great. In that case, maybe it is viable to start from the other end. And twist all this. Yeah, Tuco's still napping out over there. Is this like the opposite of ASMR? This must just be dreadful to some people. This one little section is still just super twisted. I've just got to untwist it enough to get it completely off. this cabling, or this tubing feels so bad. It's really obviously made of low-grade plastic. Okay, store that somewhere. And the cabling is free. And now we're back to this. Let's see. Snake. Oh, that's much nicer. Look at that. Killer cable snake. I expect I'm using up this whole spool. We'll see how far we get. I mean, it wouldn't be terrible to have a little bit of extra, but I don't think that's going to happen. Oh, nice. CS Water Rockets points out that this stuff comes in different colors. Yeah, I've seen some really custom color jobs made with this stuff. I mean, I'd mostly been avoiding it before because it seemed annoying to put on, but I mean, this isn't that much worse than putting on the convoluted tubing, which has its own annoyance. Kenton has his been here, done that moment. You really get used to the cable friction though. This is all getting twisted. Oh, nice. If you used this to make like an optic fiber tether for the Vive, was it a thinner diameter? Because I imagine this like half-inch stuff would be thick enough to fit the original copper tether. Oh, no, I totally agree that that sleeving is a great use for low-grade plastic. Like, there's a reason I would buy that stuff instead of like, you know, it's not like I want super expensive plastic that hasn't been recycled a bunch in my sleeving. It just makes it unpleasant to handle sometimes. Oh, that's interesting, and using recycling plastic to make drain covers. That would be interesting, because you usually see those made out of big hunks of cast iron. At least around here they tend to be cast iron. It'd be interesting. Yeah, like why aren't those made out of recycled milk jugs? Is it just a supply problem, or is it a material issue? Oh, okay, so the HDMI was copper, I guess, and that had to fit through the sleeving. Interesting. Yeah, you wouldn't want to re-terminate HDMI, probably. I see. So it was pre-terminated optical. Interesting. It's like I need to optimize this by every time I have the snake swallow something, I send it further along the snake before I let go of it. Otherwise it just bunches up in the snake's neck. And yeah, this gets more and more annoying the more wire you have. I think in the biz they call these order of n squared problems. Oh, Mikkel's asking why they added Ethernet to HDMI. I thought that was for spreading Ethernet connection between your home theater components. So like you could have one doodad with a network connection and then have that shared to the other doodads. But I mean, I guess people just use Wi-Fi these days, or they don't care, one of the two. I mean, it would be kind of useful if I could use it to spread Ethernet around my shop, just given how many HDMI cables I deal with, but it seems like nothing actually supports it. It was just another buzzword for the cable manufacturers to add. Yeah, I don't know how people rely on Wi-Fi, but maybe if you like have a house in the suburbs far away from everyone else, then Wi-Fi is fine. But like this concrete building full of machinery, Wi-Fi is not so great. Oh, I think some of these wire ends are starting to curl a little bit, which is also not helping. Not in proper buildings, ouch. Yeah, I find Wi-Fi sucks in all sorts of buildings. It's not necessarily that much of a connection between how good the building is in general and how good Wi-Fi is. Sometimes it's inverse because the really good buildings have more people with access points in them. Oh, modern building. I don't see a lot of those around here either. I mean, I guess there's some modern construction in the Bay Area, but most of it's like luxury condos. So they're the kind of buildings you walk past and scowl at instead of actually getting to see the inside of. Just looking at the glue up, and it seems like it's still relatively fine. I still remember like actually running Ethernet wires for like a home network at home when I lived with my parents. helping my dad out in the crawl space. Like Wi-Fi I don't think was at all viable. I mean, you would have needed separate Wi-Fi routers upstairs and downstairs anyway. And it wasn't like they lived near other people, but the technology just still wasn't very good. And so I think we were running cables for 100 base T Ethernet. I think they still use those wires we put in. Oh no, they wouldn't, because they've moved, but I guess before they moved, they were still using them. Who knows if the new owners of the house care? They're probably like, oh, somebody's janky Ethernet. We're just gonna ignore that and use Wi-Fi. I mean, the previous owner, well, not owner, but the previous renter here probably spent some time installing like telephone wires and stuff that I don't have much use for now. Okay, now I'm trying to like push this further down. I'm trying to kind of block this here so it doesn't expand, and then kind of work that non-expanded section down. Oh, is there a problem with YouTube chat? Oh geez, we don't need to hear about a bot's penis. Why do bots even have penises? Oh man, there's so much of this. Oh, there's still a lot of this. There's still a lot of this. And oh man, I think I need to go further down the wire. I don't know, I just got this big, really thick part here that I need to push down. Ryan's just gonna clamp it and walk down. That's a good question. I was thinking about that, but then I didn't really think about, I guess I've got some of these. Will these fit? Oh, this hand is just like out of strength for holding. That seems a little forceful. Oh, this one's a little weaker. Great. Okay. Let's try that. Let's try from right here. Oh, yeah. It just has so far to go. I don't even know if the clamp was necessary, actually. It doesn't seem to be trying to unspool over there. Maybe I was just overly worried about that. maybe it's time to go back to the front. I don't see any other really backed up areas. Take this off. I'm a little worried about the clamps damaging the cable. Ken was saying a wire in the tube. Wire in tube in tube. Oh, you mean putting a small tube in there and then putting the wires into that? Like a small tube made of a different material or something? Oh, outdoors. Well, if you want the, so I assume you'd be using like outdoor rated cables inside of some of the sleeving, and you'd assume this is permeable to the elements. Oh, interesting. Are you imagining that would be a really long tube or a short tube? Because I think with a short tube, I'd still be limited by how much I can bunch this stuff up. And if it's like, I think it would require a tube that's larger than like the height of a person, which might make it hard. Oh yeah, the Christmas tree netting, huh. So I know you can bunch it up a lot, but I guess I'm still running into the limit of how much you can bunch it up, and that's part of what I'm having the trouble with here, so I don't know if that would fix the problem I'm actually having trouble with. Wall mounted. Yeah, I mean, I'm having a little trouble following how to apply this idea you're having to my current situation, but feel free to chime in with suggestions. Yeah, 2 could just help this. Huh. Somehow this is not seeming like the kind of idea that will help right now, but maybe you can prove that it will help. I don't know. Like, the bunching up is still the main problem I'm dealing with. Like, I just have to create a little super thick cable snake and then go to its other end and start relieving sections of it. I hope this cable ends up lasting long enough. I imagine if I can find bad sections in it, I can probably splice those sections. This also might be a little easier to do, just running around the room instead of trying to keep it all in frame. But I don't know. Oh yeah, there are definitely machines for putting this on. I don't have one of those, obviously, but many people do. I'm sure I could find somebody that would sell me exactly the right cable thing that I wanted. That seemed expensive and complicated, whereas at the time this didn't. Starting starting to warm up in here. Either that or maybe I'm just getting hot. Oh no. Oh my god, what are we getting in there? Hello, mouse. What input devices can I use to ban this asshole? Let's go to the other computer. Is someone else doing it? You fucker. Oh. I was trying to delete them, but someone else was deleting them faster than I could. Thank you. Man, that's either a smart bot or a really dumb person. Can't really tell. Either way, it's probably a mistake to think too hard about whether it qualifies as intelligence. I'm assuming that was a person because that was the same spam we just saw in the YouTube channel, which... Oh, geez, and they're back in the YouTube chat. Oh, blocked again. Really? Did they pay you to do that? Or are you just like promoting penis pills of your own volition? I mean, I assume that someone's paying you to do this, in which case it's a mighty bad investment. Also, I think Tuco maybe has more use for those than I do, although neither of us seem to care especially much. Oh, and they're back in YouTube. How do we do this? They're just creating new accounts over and over again. That's pretty neat. Now somebody's asking for Jared. So I've seen some ass in YouTube asking for someone named Jared, like, in the past, and now they're back, and I don't know what that is either. I wonder if now they're related to the penis pill spammer, or is it just a coincidence? That's super weird. Oh, we have a non-spammer. Yay, somebody asking what the stream is about. So I'm just putting together a cable snake. In general, this stream lately has been, I've been constructing a streaming robot that'll have a little gimbal camera, move around the shop, do internet-related things with my cat, so that kind of thing. That's the current project, the current little minor obsession. And then more generally, this channel is kind of a electronics engineering and reverse engineering software, taking things apart kind of channel, you know. If you want to see some of the previous stuff I've edited together, there's a video blog at scanlime.org, or if you just search for scanlime on YouTube, you'll see a lot of the previous episodes. There's kind of a combination of streams plus edited episodes when I have something that actually forms a complete story that I can tell. Details in chat is asking if I can break game engine security for them. I mean, maybe. It depends on why. You know, if you just want to cheat and harass people, I'm not really into that, but there are some pretty interesting reasons to break game engine security. I was just reading an article last night from the new issue of POC or GTFO. It was the latest article from 4 a.m. on their progress on reverse engineering really old Apple game copy protection. So that was pretty cool, and that's definitely a case where, you know, you've got to crack some game's protection, but in this case it's, you know, because this game had not been preserved anywhere, and now people can finally play this thing that would have just died otherwise. And then, you know, there's plenty of good reasons to hack on stuff to learn how it works. I mean, I learned tons just figuring out how Nintendo stuff worked in the past. So it can be lots of cool reasons for that. Well, it's nice to have mods. Thanks so much for the attention. I am getting close to the end of this cable, too. I might actually have more tubing than I need. This is feeling a little bit... Well, I've got some sections here that still need to be smoothed out. But let's go ahead and put a little more of this on the wire snake and then smooth it all out, and then maybe we'll have enough on there. And maybe I have a little bit of extra braid that I can save for some other stuff. Oh, that's a good question from Whisperfists in chat, who asks if anybody knows the story behind the Adafruit logo. And they'd always assumed it was a slice of starfruit or a carambola. I remember having some of that. I think... Oh, when was that? I think I was on an airline. I was like flying to Thailand, and it was like a Japanese airline on one of the trips, and they had... Maybe that was something different, but I think they had some of that as like a little chunk of fruit in one of the meals. It's like so much better than any airline experience I've had in the States. That was also a while ago. Oh. Yeah, Details in the YouTube chat was asking what I'm doing with this wire, but yeah, I'm covering it with this sleeving, which is mostly to protect it as it like kind of wobbles around in the sky. I mean, it's not super necessary because I already did coat the wires with these little bands of tape just to keep them together, but this will help keep them together more, and I might end up needing to pass this through a pulley at one point so that I can control how much cable is up there, and there are various things that might be nice about having the sleeving on. I like the idea of having some kind of protective sheath over the wires, and so I had been using this crinkly stuff, which this is a much better replacement for. Oh, it looks like we got a picture from Ken. Make that bigger. If I have the right mouse. Oh, that picture wasn't updating. I don't know why my video grabber freezes like that every so often. The other recorder that I use for doing my edited videos has been a little more reliable. But at least when this one breaks, I can see it. I assume it's something software related, although it certainly could be a hardware problem. Yeah, Is this all of the braided sleeving? Because I think the problem is if this was like all of the sleeving you wanted, then it just wouldn't fit on here, because we were already running into the limit of how much you can compress it. If there is a way of feeding more tubing in, that might be nice, although I think that just presents the same geometry problem we've been hitting. I'll have to think on that. But I think we might be almost done with this job. Let's do a little more. And I'm hoping maybe I have a little bit of extra braid on the other end and then some of a spool left on this end. Okay, so now let's try to smooth this out as much as possible. I'm just going to try to get most of this mass over to the other end, and then I'll take a more thorough pass. Oh yeah, I need the Klein bottle version of this. That would be great. Oh yeah, and then Piotr mentions the split tubing. Yeah, the convoluted stuff was split, and I have some of the tools that work with that. They sometimes help. Oh, I need to give the chat a kick. Oops. Oh, I think those little orange tools are probably the same ones I've got. Ha! The end. We have an end. Okay, let's just try to smooth this all out now. Oh, there's actually still a decent amount of extra wideness here. This really is a good way to warm up your hands fast. When you smooth it all out, you find you'll have 10 feet extra. Yeah, pretty much. Oh yeah, I'll be able to save this for some other wiring at least. This is nice. Okay. Well, let's cut this end at least. Oh, they recommended a hot knife for cutting this stuff, huh? Can see why. Do I have an easy solution for that right now? Well, that's probably not finally where I'm going to cut the final end for it anyway, so. Let's just take another smoothing pass. Mikkel suggests squeeze it with hot pliers. Melt it with a heat gun. Yeah. Yeah, a heat gun might be convenient. I've got one of those right here on the desk. Whew. Ouch. That got a little too warm. Ouch. Oh no, is there more spam? Wow, so are each of these spammer accounts then backed by a spammer account on Twitter? Is that how this works? Oh man, we're so happy for that bot's inches. All right. Well, cool. So I think the way this works, how do I trim this? I mean, I guess I don't need to worry that much about keeping it super tight. Maybe I'll just start by cutting it and then hitting it with the heat gun. I could also, I mean, I have like a soldering iron with a heat, like a plastic cutting tip I could use. Well, let's try the heat gun first. I think that might be the easiest thing. Let's just maybe give it a little extra room so I'm not torching the cable while I'm at it. Oh. Let's see what that did to it. It curled up a bit and seems like it might not unravel now. Not quite as reliable as like the pliers approach, but I can also terminate this a little more properly once I have something to attach it to. Just hit the other end maybe. It's fun at least. I don't know how effective it is. I want that to be a little closer to the end, or to the cables at least. I'll suggest is to hold the braid between tweezers. So the thing is, I don't want to completely close it off though. I think I want it to still be a tube. So that's why I don't think that approach is what I want. I mean, a hot knife does sound like the best way to cut it, but I think this might be better than nothing until I actually do something proper. Yeah, Peter says a hot braid might be... Oh, I could also heat up a piece of metal and then press it against the piece of metal. Okay. I was getting antsy to do something else and was aiming for a temporary solution, but I guess we can do a less temporary solution. Everybody suggests the less temporary solution. So I think what I want then is to cut it pretty close to the end, or maybe actually to compress it a little and then use a hot knife. I don't know. I'm just imagining, yeah, I really just want a hot piece of metal. I'll just get the soldering iron. Running a little low on patience already. All right, I'm gonna plug this in and get some water. I'll be right back. Oh. How close to melting plastic is this? I think it's got a little ways to go. This is not as fast as my my Heiko 951. It's starting to get a little melty. Let's check on the printer. So that's the infill for the main kind of mounting bracket for this test that I'm printing on the left, and then on the right you can see some support material, and then it's working its way up to the actual bracket. That whole pattern on the right is for the motor mount, and then the holes in the center are for bearings. Heat shrink. Oh, that's a good idea. I was just catching up on chat, and maybe someone was suggesting heat shrink for the ends of this, or was that out of context? Yeah, do I have any heat shrink wide enough? Because that might be really nice. Maybe I do. That could be nice. Let's see if this actually fits. This is difficult to get it over this BNC connector. I don't know if that's going to work. Yeah, the BNC connector is too big. If it was just bare wire, I could put heat shrink over it. I could cut off the BNC, but I don't think I want to do that just for this. Okay, so I want something that comes out and stops, like right about there, I think. So that means I push it back to about there. Man, doing this without melting the wire seems like it's going to be hard. Can I put something behind there? Oh, I could just use something like a popsicle stick as backing, and then kind of move that along as I cut and melt it. How well does this work? Well, I can do that. Alright, I mean, that seems okay. Maybe it's a little longer than I was expecting, but that's fine. I can trim it if I need to. I guess the actual length I want kind of depends on which end this is. You know, actually both ends I kind of want more of this whole thing exposed. How well did that actually work though? I don't think that's gonna fray. Let's maybe try. Put some popsicle stick down here and cut it a little more. You can kind of even just keep the stick and the wires pretty still and just rotate the plastic. Kind of. Until it just gets too twisted for that approach. Scoot it as far down as it'll go now and see how far that is. Ah, that's better. That's enough to work with on that end. Man, that's producing a lot of smoke. At least it's a warm day and I'll want some ventilation anyway. Okay. much extra? Well, I guess either they gave me more than 100 feet on this roll, or I've got a lot less than 100 feet of tether. And the other end. Alright, so we want more of this free on the robot end, which I guess we could decide this is, since it has to go somewhat deep inside the robot. So robot smoke, don't breathe that. Well, there's only a certain amount of this I can cut super well with this tool. I could trim off more with the scissors. So let's get one of the carbon fiber rods. I want the exposed length to be maybe half of one of these rods. So okay, let's do it there. I want to turn off this hot knife because it's stinking up the place with molten plastic fumes. Popsicle stick. Alright, so now when I squidge this all the way, yay, that should be enough. This will go down to the camera, this will go to the power converter, this will go back up to the micro, which maybe means I take this tape off. And we can unplug the hot iron. Thank you, camera. Oh, cardful. Oh, US Water Rocket says that I probably have more braid because my cable's thinner than the specified diameter. That's probably right. Okay. Well, I guess the thing that this attaches to next is this strain relief. So we looked at this on an earlier stream, but let's see how this fits onto our new cable braid. These are two PLA pieces with a Ninja Flex piece inside, all held together by M3 bolts. Oh yeah, so Brandon in YouTube chat suggests they usually terminate this sort of protection with shrink wrap, the glue kind, or they roll it back on itself inside to make a soft edge. Oh, that sounds really good. Yeah, I'd love to use heat shrink for this. I think that would require like re-terminating the BNC, which I've been trying to avoid. But that does sound really nice. I think I just need maybe a better selection of wide heat shrink. I have a couple of specific sizes. I have one that's a little too small, and I have one that's way too big. Alright, so this fits over the wires. The difficult one first. Okay, so that's still a pretty loose fit. Let's see if we can tighten it up with this piece. That's promising. I was just briefly thinking, oh, should I put this through the other pieces also? I probably should, but I can put the other piece, the other end of this cable snake through. Let's not pull that off the table. It's probably still hot. That seems just right, actually. It's got a good amount of grip. Doesn't feel like it's breaking anything. It just has a decent amount of squeeze. I think I got lucky with calibrating the size for that. I mean, I did my best with measuring the cable and trying to imagine how these pieces would fit together, but I didn't have a lot of confidence in it. Oh yeah, Mikkel in chat says the cable condom turned out nice. Yeah, I think that worked out pretty alright. So yeah, that has a pretty good amount of grip. And that'll hold on to the carbon fiber rods at the top of the robot. And this will plug into the relevant pieces of electronics. So I think I can just leave this on here for now. We might have to adjust it a little bit later, but that's mostly the right positioning. And then the rest of this cable snake can start to go through the relevant pieces in the robot. Oh, there's so much of this. This is also all going to be hanging from the ceiling for the most part, and my plan so far is to use bungees to help it coil up and relax to try to match the height of the robot. So the goal with that would be to have the bungees hold a little bit, or to have the bungees pulling upward with a little bit more than the weight of the cable, and then the robot's weight would kind of pull it the rest of the way down, which seems like it'll need some tuning. There's the other end finally. Oh, Rob says I might be able to sneak the BNC and wires in one at a time now that I've got more of the ends exposed. Oh, that's a good idea. Yeah, I'm not too fussed with the, so on the other end, I think I'll just leave it bare like this because, well, I've got this strain relief, and I think I might actually end up wanting to cut off some more of this, or even just fish the Ethernet wire up higher, because the Ethernet, well, actually maybe not. The Ethernet wire, the Ethernet jack is actually up here, but it can just loop around and plug in, whereas these want to go down to the bottom of the robot. Anyway, I can adjust this. Yeah, let's see if the heat shrink fits over this. I think it would at least be worth heat shrinking this side if we can. So this is the stuff I had that was close. I think it's 1/2 inch clear heat shrink. Oh man. Yeah, this doesn't even fit over the BNC by itself. I mean, it might if I stretched it a little bit, but then it wouldn't fit over anything else. Although it doesn't really need to fit over anything else. If it fits over the BNC, then we're good. Is this any bigger? These look like they're the same. I think these are both 1/2 inch. Oh, 12 millimeters. This is not as big as the other piece, I think. And then this stuff, I'd have to take apart the connector to get this over. I don't think that's worth it right now. But I'll keep that in mind. This end, I'm not quite sure how I'm terminating it. This goes to equipment in the rack if it makes it all the way down. So if I need to extend it before I make it to the rack, I might have to plug this into something else. If this can go all the way to the rack, then like this is going to a distribution amplifier, and this is going to a power supply, and this is going to a network switch. So they might all end up going to little couplers that then send them elsewhere. I think that's all right for now. Great, well, let's put this aside and work on something else. I think this is everything we need to do to the cable snake at the moment. It's got a little bit of noise to it, but I think it'll be better. A lot better than the crinkle. Certainly thinner. Oh, I think I need to clean my magic arm. I think if I lock it right now, it's gonna, yeah. I think I need to actually do this. At least I think I've got a system such that I can do this pretty quickly without even taking the camera off of it. Well, maybe I take the camera off of it. I think holding this camera is not where I want to be. At least I think I made that part easy. One piece of Velcro, and then one clamp. And then the camera comes off the arm. And I sit the camera down, and maybe we switch to the other camera for a sec. Or we could have cat cam while I clean the lens, or clean the camera arm. Unless people like really want to see me do this. But there's a really fiddly ball bearing in here that I've got to maintain a little bit. Yeah, it has this clamping assembly where it actually uses ball bearings as the clamping element, but sometimes these two bearings can end up both hanging out where there's only supposed to be one. And then every time you clamp it, it's like it's breaking itself a little bit more. So I just put the ball bearings back in the right place. Now I've just got to tighten it. Sound. Oh, I think it's fine after that though. Great. Oh, this is in somewhat better shape. Okay. So, a few more things we could do. We could take a look at this. The glue is still under there. I'm kind of tempted to let it sit more before doing more with it. So this could be a time to wrap up the stream, or we could build some of those little LED saucers. I think I've got an LED saucer in me, but I do kind of want this desk space, so maybe I carefully move this elsewhere in the shop. Okay, I'm going to carefully put this on a different desk and be right back. You'll know if the glass breaks. Okay, I think that was uneventful. I'm sure at least some terrible person out there is going to be cheering for me to break the glass and cut up all my limbs. Now we can take a look at the glue over here, looking at the remainder of what was in the syringe. Whisperfist is asking if there's discernible air movement from the top of the rack. I mean, there's definitely heat rising up from it. That's a lot of what he likes about it, for sure. There aren't like fans pointing upward or anything, but there's heat rising. And I think just generally it's a pretty warm place to hang out. So this is still going to need some more time. Okay. Well, there's some more bot assembly we could do, but I think a lot of that wants that top piece to be further assembled, so let's put that off. Let's just work on the LED rings. Your server way off. I'm gonna put some of this stuff aside. Oh yeah, how's the print looking? Still printing those little waffles. Okay, so this is the last one we made. Let's try to make two more. This is a ring of LEDs with some diffusion. Fits on a little stacker here. Lights up. I can do a few more of these. So these are each made out of two of these pieces, one of these, and an LED strip. Oh man, now they're pouring asphalt outside and I get that smell. It mixes with the burning plastic from in here. Okay. 4 of these, 1 of these. So I think maybe the next thing to do is to prepare these 2 LED strips. Yeah, this one actually was already prepared, so we just need to do one more. And so we did this with some lengths of, I think this is 24 gauge silicone wire. Yeah, 24 gauge. And then I mostly have white silicone wire at this point, so I was using little snippets of heat shrink to identify them with colors and patterns. So the yellow and green are clock and data respectively. And so the single yellow and green are clock and data in, the double yellow and green are clock and data out. and then power are red and blue. Oh man. Yeah, so Fran has this, she actually made this whole video, actually, I think after, I think I noticed that on YouTube after we were talking about that on stream last. She did a video on her cutting wire techniques. She has actually some pretty cool little techniques that I might try to copy. So she had a setting, or she had like a station with some spool holders for big wire spools and for little wire spools, with a couple of little tricks like a strip of neoprene on the front. And the thing that I think prompted her to make that video was the comment she mentioned in her previous video on the, I think she was making wiring harnesses for the Sputnik kits that she's doing. And for that, she needed to cut lots of wires that were all the same length. So she ended up using straws, which seemed really cool. And I should get a packet of drinking straws or something, but I could 3D print something, although that seems like a lot of time. Like 3D printing a straw is very slow. These don't need to be super exact. I'll probably end up trimming most of these again. And then, I also really like this thing. I got this a while ago when I had an art project I was working on that needed lots of little tiny wires. This is my first automatic wire stripper, but I like this one a lot. It has little grippies at the front that are actually pretty good even for silicone wire. You can set the length of the stripped section. You can set how much force it uses during the grab. So in fact, what I usually do with this is I'll just kind of fan out a little grouping of wires and just go after each of them with the automatic stripper once I give myself enough space. So I'll have a little fan like that. And like that, and then switch sides. If you're using a solder pot, you could actually do this and then tin the wires pretty much in one motion. That one didn't quite open up all the way. Breaks my rhythm a little bit when there's an accumulation of cut-off insulation ends in the cutter and then it stops working, but there we go. That was mostly smooth. And then tin the ends. Put some heat shrink identification on them. Scrape off the solder mask. Oh, Mitch says down in the comments on that video, Mike's Electric Stuff proposed a method for winding wire around a cylinder with the same circumference as the desired wire length and then cutting longitudinally for lots of wires at once. I did that a while ago for, it was while I was working on preparing a whole bunch of webcams with the same little serial port breakout mod. I needed a bunch of little pieces of magnet wire. So I wrapped magnet wire around a cardboard tube. Then I used that to sand the wire to strip off the insulation, or to help strip off the insulation. So I wound it around the tube, sanded it, then cut it. I used tape first so that it held together. So then I ended up with like kind of a strip of wires that were already stuck down to the tape. And then I could grab a few of those at a time and stick them in the flux and then stick them in the solder pot. And that worked pretty well. That was fast. I mean, at least as far as those things go. Oh, and then in the chat, some folks were mentioning, I think, that the diameter of the tube might be a problem. In my case, I just used whatever tube I had handy, but then I just marked out 2 cut lines. So I had some wasted wire on the backside. I think what I did is I spaced out like 2 cuts along the circumference, and then I had one that was a little bit shorter, and so that one was wasted, but then the other 2 were the length I wanted. It was something like that. I forget. Maybe I just made the wires longer to match the circumference. Okay. And then some colors. Or are we in need of more moderation? I think the chat looks fine. I think folks are happy. Oh, I was just picking out all the colors, but of course I already had the colors I was using over here in this pile that I forgot to put away last time. So, and then I'm trying to put these in a position where they'll be easy to notice even on the exterior of this LED ring assembly. So I don't want them way over here because I might be trimming this part of the wire. I don't want them way over here because that I won't be able to see, but over here I think I'll be able to notice pretty easily once this thing is fully assembled. Oh, and then Fran was also speaking really highly of silver Teflon wire. Yeah, I haven't used that stuff in ages. I think this like aerospace kind of thing that I used to work at, we had some of that around and it was really nice. But I haven't actually had occasion to order it for myself. Maybe I should. The silicone wire is good, but it definitely does not hold its position if that's what you're looking for. Am I one wire short? Maybe I am one wire short. I meant to cut 6 wires, but I think I cut 5. This heat shrink just really likes to stick to the wire. It's just only a little bit bigger than the wire diameter. Alright. I keep getting whiffs of that E6000. Is that coming from this little thing? Put that a little further away. There's just a pot of extra glue in the syringe still drying. This is not super necessary since I was just complaining about how sticky they were, but this will prevent them from moving around any further. Okay. Now, microscope time. Okay, so let's work on the input side. This is where we need to connect everything. Okay, so these for power and ground will be fine, but we need to clear off these pads again. And there were some comments last time I did this about the composition of these boards, and it seemed a little weird, like there's a layer of epoxy, and then a layer of Kapton tape, and then another layer of epoxy. Let's get this microscope a little closer. And there was also a suggestion, I'm sorry I'm forgetting whose suggestion it was at this point, but someone suggested maybe that I could get the whole thing off by just scoring the edges and then kind of peeling it away. That might be worth a try. That top layer is a little bit, like it doesn't seem like I could take it off all in one piece. It seems like the top layer might be more flexible, but it definitely seemed like that bottom layer of epoxy wasn't bonded super strongly to the copper, and it was easy to kind of flake it off. Okay, well there's the copper. I mean, it does seem like, I don't know. I think the Kapton maybe is tearing before it's helping me remove the rest of the epoxy, but starting on one side and then going over does seem to help. I just momentarily couldn't tell which of the shaking was coming from me and which one was from what sounds like a giant truck outside. Oh, and I think someone else was saying that the substrate on the board might have been the Kapton. So they might, because it's a flex PCB, right? So maybe they build copper on Kapton, kind of a regular flex PCB process, but then there's another encapsulation they do. And that's like a solder mask on top of the Kapton on the other side, I don't know. I guess that would imply that they're assembling the whole thing. Yeah, how would they cut the Kapton then? So is the Kapton cut before it's applied to the copper? Is it Because you can't, like, chemically etch Kapton. That's not me. That's not a truck either. That's neighbors' exercise machines. Or maybe they're just doing jumping jacks. Oh, that was the closest to like a full peel that I've got. See that? If you can see anything with all the shaking. Geez, I'm gonna have to make sure that when I do Andrew's PCB rework capture the flag that my neighbor is not exercising while I'm doing anything delicate. Had my finger here and I momentarily forgot which things were really sharp and which things were just kind of sharp. And so I felt the sharpish edge of the LED strip against my finger and I was like, oh no, is that the sharp edge of the knife? No, no, that's something completely different. Okay, that's plenty clean. Look at all the wires sticking to my arm now. Okay, let's tin these, and then I've just got to figure out which wire goes where so I can carefully apply them all correctly. That'll do. There's a few spots where the Kapton is not fully off, but that's plenty of contact area. So here's another LED strip we can use for reference. On this one, green is on top, blue is on bottom. We should have negative on top if we look at this. Ground, yeah. Alright, single green. And these I want to be pretty much perpendicular to the circuit board because they're coming out kind of a little narrow channel in the LED ring. Okay, green. Oh yeah, this will work better if I put flux on the board. Let's do that. That was an okay solder joint, but it'll be better with flux. Where's my flux pen? Under DaveCAD. So you might also notice that this is right where a splice is between circuit boards. It's not ideal, but that's how it ended up. All right, that's data. This will be clock. And ground. Oh yeah, someone's mentioning the LED strip being made in tape. Yeah, they don't manufacture it continuously. They manufacture it on like basically normal pick and place and reflow kind of equipment. It's just a lot of it is really, really wide. I saw some equipment like that for sale. I think it was on eBay. And they would process like several of these side by side, and then that whole thing would be like a meter long. So really extreme aspect ratio on the panel still. But then they have to have these joins still. All right. Seems fine. That's all the cleaning I feel like doing. I think that's fine. Let's do the other side. And I think we've got all three of these LED strips prepped. So over here, same deal, we need to remove those two pads. Those are the only two pads we need. Anyone else having trouble with the stream? YouTube says it's fine. It says there are 51 people connected happily. Well, YouTube has no idea if they're happy. It assumes they are. Algorithms, like most humans, have no idea what happiness actually is. Can we have some more magnification? I'm kind of just pushing the tip of the knife over the epoxy, trying to break it off, basically. It's tempting to do a full disassembly on a dead section of this board. Like, I've got some extra LEDs from there's one that I took off of each end that I didn't use, so we could just do an autopsy if we wanted. Try to figure out what these different layers are actually for. Probably worrying a little bit too much about going through the copper. Being a little too gentle with this. Tin this, then some flux, then some wire. And this one I want to be parallel to the board, kind of pointing out in the same direction. Okay, and green should be toward the bottom of the frame this time. Yellow on the top. Warm and cool colors near their neighbors. I need a little more slack on my soldering iron cable. All right, green. Oh, did I not put flux on there yet? Alright, those should be good. Oh, James was suggesting that maybe scrape off just some and then add some heat and solder. I mean, that was kind of what I was doing the first couple times through this, but I think it's much easier to get it off with the knife. I mean, there might be a different balance to hit, but it wasn't coming off as easily with just heat as I expected it to the first time through. Okay, so these should be done. It would be nice to test them. Maybe we should do that before encasing them in something hard to disassemble. So I've already got a rig over here that's mostly put together for testing these. We can first, well, I was going to say we could do a control test by just plugging in something we know that works, but I mean, these are LEDs, it's not rocket surgery. So let's just try plugging one of these in. Do want the polarity right. So we'll have power, 2 data pins, the yellow data and the green data. Those are totally what those wires are for. And then the outputs, I think, we have the option of either manually testing with the scope or daisy chaining them to another strip. Maybe I'll daisy chain them. Well, I can't test both of these by daisy chaining, so let's just go ahead and get the scope on. Warm up the O-scope, get at least one probe attached. Might as well have 2 probes. Oh, I was thinking, oh, I turned on the O-scope and now the CAD screen is flickering, but I think I opened the drawer that had the probes, and then the drawer was resting on the space mouse, and then something in there was causing it to redraw and flicker. Okay, so this will need, I'll need power for this little board, and I'll need to send it some data from, the most convenient way to do that is from a Raspberry Pi that I have running a little Rust program. Well, let's see if the Raspberry is still running. A little bit of software. Oh, that might still be running. Oh, keyboard, come back. Okay, I think that's still running. We can just ignore this if it is. So, power. So you might see that the third channel is set to 5 amps, or 5 volts at a 1/2 amp max, and the second channel is 5 volts at 1.5 amps. Third channel is our microcontroller. That looks happy. And the second channel is our LEDs. That also looks happy. Yep. So let's see if the pass-through output on this is still good. These both need some grounds. They won't be great grounds. And then let's match the colors, because we can. I happen to have green and yellow scope channels. Oh, and there's our pass-through data. Not the prettiest, but we've still got a pretty good eye there. And you can see the little blips moving around in the frame pretty clearly. So what that tells us is if we connected another LED strip there, then it looks like it would be getting data that's just fine. So this strip checks out. Let's try the other one. Take the power off. Oh. I guess I just tested. So I tested the one that we didn't build today. We must have built this before. I was just realizing that I think I want to resolder. The little outputs here are pointing not the direction I would want them to point, so maybe let's actually change that. And then technically I think that means we need to retest it, but that should be pretty quick now that we've got the setup. Okay. All right, for completeness, just quickly plug this in. Oh, sorry. That's what we're doing. Okay. Just noticing what I think is some stair-stepping from changes in that 32 level master brightness for each pixel. I have this calculating the pixels in like a linear RGB color space and then doing some really hacky math to try to make something that uses the overall brightness control, and I think I need to spend some more time making that nicer. But anyway, the LED strip works. Let's try the other one. I made these wires really small. I don't know if this is going to work. Yeah, that's not going to work on its own. More stripping. I can't strip it with that tool after I've tinned it. I'm going to have to redo all of these, they're all too short. It's annoying, because these aren't really the final wires I even care about, it's just I want to be able to plug these into the breadboard. I was just being a little lazy and stripping these all with the same setting, but really the end that I'm testing could use to be a good bit longer than the end that I'm soldering at the board. Let's try that. Much longer. Some of these are going to be a little end heavy. A little bit of solder tends to accumulate on the very end of these wires, so trimming that off will make it easier to use them with breadboards. Let's see if that helped. So ground, power. Definitely easier to plug into the breadboard now. Well, maybe except for the one that I made too long, or too wide. I think that one was a little wide. It might still be. I think that's in. It's more fixable than the wire being too short. You can just kind of force it in. Okay, this is ready for power. Nice. And the O-scope says, cool. So those are ready to mount. Let's start warming up the black hot glue gun. There's the giantest fly under there, and Tuco is not yet hunting it because Tuco is asleep. Alright. I can unplug this again. Alright, so we've got these two LED strips and all of these plastic parts. So each of these wants to be built on one of these bases. This is mostly me trying to get the wires to go into the slot they're supposed to hang out in. Oh yeah, I wanted these going clockwise, didn't I? That's the opposite of what's happening here. I mean, they're reversible, so I can flip the entire ring, so I guess it doesn't really matter. A little bit of interference between the very end of the LED strip and the wires for the other side, but I think I just have to put this together pretty carefully to avoid that. And I was worried about protecting the ends from shorting against each other before using like some Kapton tape. I don't think I have to worry about that given how Well, I don't really see a way for this to short out. And the short we're looking for isn't like across power. The short that we're worried about is like data in to data out. So worst case, this particular LED strip just wouldn't work, and the ones after it might not. But this is close. I mostly just need to keep the wires in the channel where they need to go, and then put this on and glue it all together with some clamps. John asks if you tried switching back to clear hot glue after using black in a glue gun. Yeah, to see if there'd be residue. Yeah, that's a good question. That's partly why I'm using this in a different hot glue gun than my big old Sure Bonder, because that one I just use regular hot glue in. I had some wider black glue sticks that I used to use in that. I think they cleaned out all right. I think there maybe were some little boogers of it left over for the first clear glue stick I put back in there, but I don't think it was a big deal. Kind of like switching colors in a 3D printer extruder. I think this time it's just like I ended up with a batch of these really thin ones, and it's just, these are the hot glue guns I had that worked with it. Yeah, we could try that, because I have, I think, some thinner clear glue sticks. We could try putting that in here after this black one's done. Oops. Speaking of black hot glue, dribble, dribble, dribble. At least that comes off the silicone wires really easily. And just as easily, more of it on. Delicious and warm. Okay. I'm going to try holding this end on with a clamp while I try to get the wires in on this end. All the wires and the LED strip in the right place. Yeah, it's neat when the thing that needed to happen for this to make more progress going together is actually just moving a wire out of the way. Little wires. Oh, is that it? Almost. Yeah, okay, I think that's it. I think it just needs some pressure and some gluing. I'm gonna take this clamp off because I need to make sure these are actually rotationally lined up, which they weren't quite. Thought that was good. Maybe it wasn't quite. Feels like it's caught on a wire somewhere still. Maybe like the LED strip just isn't quite fitting into the channel. Ah, is that it? probably something I could have chamfered to make this a little easier. Okay, I think that's it. Oh, maybe not. It still feels like there's something catching around the wire area, but let's at least clamp the rest of this since I think the rest of this is good. At least enough of the rest of it that I don't keep messing it up again. Okay, now the problem's up here. Quite want to close right here. Oh, is that it? I can't tell if it's a wire issue or an LED strip issue. It might be son of H. I keep finding areas where it's sticking and kind of playing whack-a-mole. Oh yeah, so this particular hot glue gun is a really cheap one. This was like a $3 hot glue gun. It's one of the ones that I got a bunch of for classes and stuff. The nicer hot glue gun was more like a $50 or $60 hot glue gun. But I think that one has worked fine with the black hot glue sticks in the past and cleans up fine too. Oh, this feels like I could maybe force it together, but it isn't quite actually fitting flush. And so it's gonna be like a bulge that I have to do something with. What to do except take this apart. Oh. That looks like the problem. This edge of the LED strip was kind of curling up instead of sitting in the channel it was supposed to sit in. I'm just using this clip to bend it back into place. See if I can put that back together with minimal disturbance. Oh. Is that it, or is it just close? I don't think it's it yet. Oh, Servo AF is really not doing very well right now. Oh, come back. Now it's sticking to the top. could certainly be related to this extra little end of the LED strip being soldered on at a slightly strange angle. I don't know. Could also just be wires interfering with other wires. This feels really close. There's just a little bulge right on this side that I'm trying to get rid of. Yeah, I wonder if this is that LED strip end. I wonder if I could trim it a little bit. Oh. No, maybe it's just the same problem. I've got this again. So maybe let's try to get that edge to fit into this assembly before we move on. That seems like the problem. Yeah, having maybe a more forgiving slope on that little retaining edge might help. Also, if I can just manually guide that in on here. Oh, so you can see here, even with this whole thing open, I can't push that quite all the way down compared to where the other diodes are. So these diodes are sitting pretty much right at that level. So they're pretty much lined up with the edge of the diffuser. And then over here, it starts to raise up. So is this a problem with the plastic or with the LED strip? Oh, there is maybe a tiny plastic booger in there. Yeah, I'd never seen the black hot glue sticks locally. I got mine on Amazon. I forget exactly where, but they were pretty easy to find once I went online. I don't know what the really common uses for them are. Like, do most people use them for assembling LEDs? think this is the LED strip itself being a little bit bent at the end. I'm going to try to trim it. Okay. Thank goodness this isn't multi-layer. I hope that does it. Maybe a little more on this side. This side shouldn't need it, but I'm just going to help out with a little bit of trimming. Okay, clockwise again. Just try to get this fed through the other things we need. Okay, the diffuser ring is on. And the next piece. Oh, I have that on sideways. This needs to be rotated 180 degrees. Oh, did that actually fix it? I know I've said that before. But now it feels like the whole thing is maybe resting on the LED strip evenly instead of having a bulge on one side, so that's an improvement. Let's use this to line up the layers while we clamp it, since we can. It's hard to do without the wires pre-wrangled. Let's tape these down. So the wire exits through this little gap between the two halves of the ring, and then some of the wires need to go to each side to make enough room. Okay, is that enough to at least get it on the ring? Then we can clamp it. Looks good so far. And then will this work? Okay, so by starting the clamp with it on there, I should have them rotationally aligned. Now I just want to cover this with a bunch of clamps and then start gluing it. Oh yeah, I put Kapton tape at the ends last time, but I'm not sure that really helped since the strip isn't, I think, long enough to short out with itself. And the soldering and the wires and all that, like, there's so much stuff in there that the strips aren't really flapping around at all. They're pretty well constrained. And then I just kind of squirt glue in the whole thing. Okay. So, what are we looking for? The two halves need to be lined up relative to each other, which it looks like we've got. We can double check that by putting it on the center spindle because it'll only fit if they're actually lined up. I've actually got to redo this taping before that works. I took the tape off so that I could tighten all the clamps, and now I need to put tape back on so that this is in exactly the spot where it hangs out with the glue. So I'm just going to push this in there a little. Okay, and these are easier to fit in there if you keep them in order. Has this been terribly out of focus? Sorry. Okay. Does that fit? Seems fine. Well, we could actually test this before pumping it with glue just to make sure. Kind of inclined to do that. I tend to test my LED stuff pretty frequently because it's the worst thing to fully assemble something and then discover that it doesn't work. The data wire is a little big to fit in the breadboard, but if I touch it against the post, then I can see the LED's working. Do I re-strip this wire? That one's not tinned, which is going to be bad, but okay. So it looks like that's the boundary between the beginning and the end of our strip. Maybe not, maybe it's over here. Yeah, it should be like right under this clip. You can see where the colors are different right next to each other. Okay. Well, I was just trying to make sure both the first and the last LED were working still. So let's glue this thing. We want to keep the glue off of this surface right here and 90 degrees from that, but it's pretty easy to just glue everywhere and then trim it with the knife, so I think that's what we're going to do. Maybe manual focus is the thing. I'm just trying to kind of fuss the glue around on the surface to try to push enough into the crack that it'll hold it even after I cut off the extra. Alright, and of course some under there once that glue dries a little bit. There is kind of a top and a bottom to this if I want LEDs to be clockwise, but otherwise they're completely reversible. Okay. It's tempting to kind of spin this around a little as it dries. Alright, I don't think this glue is especially flowing right now. So it's still quite warm and it'll need some time to set before it really becomes strong. We can probably go ahead and trim some of the stuff off with a knife though, if we're careful about it. This might be easier to do once the glue is cooler, actually. Hot glue. It's still a little bit warm, but it just kind of freezes onto the knife. Okay. We can take a little more off later if we need to, but I think that's probably most of it. Okay. Let's put this aside until the glue cools, and let's work on its partner over here. The third of these rings. So I've got this one, some junk in it. I don't think I've tried putting this one together yet. I mean, it starts out looking pretty straightforward. Opposite side is pretty much in. And then it's kind of picking the wires out of the gap. Or pushing them through or whatever. Actually, this one might need more organization. I definitely could have made these wire openings a little bigger. Save myself some of this trouble. Very close. Oh, I've got one spare clamp. Great. Hold that side on while I work on this side. I think the root cause of this problem is the channel here fits nicely when the LED strip is pretty relaxed, but the extra bulk from this wiring, without quite enough cutout behind it, is pushing the LED strip forward up against the edge of the channel that it has, which makes it really tough to actually get it into both sides of the channel. Maybe something else is going on too, though, because it looks like the LED strip is a little taller here than I expected to be. Do we have something else to clean out of the channel itself? Oh, maybe. You know, I printed all of these from the exact same G-code, so it would make sense if they all had very similar defects. Yeah, that looks like it'll help. There's a little plastic booger right where the thing was not closing. In fact, the plastic booger was there pretty much because of the wire hole. Interesting. Is that any better? It still does not look completely flat. Let's try the other technique I had of... Oh. Well, I was going to say, maybe the other one was flared outward because of the join, but maybe they're just flared outward a little bit because of how they're cut. I mean, this wasn't where the original end was. It just looks like it might be bowing outward a little bit. Let's just trim this. Something like that. Shave down the edge. Here it is. Okay, clockwise. Let's try clockwise. Okay. That is partially assembled. Let's see if it'll fit the rest of the way. This one doesn't have quite as much of a satisfying closure, but it feels like it might be together. I'm trying to make sure I'm not closing it on some wires in here. Yeah, maybe it isn't quite in. Oh, was that it? Oh, that was in on one side. Oh, I need more clamps. Let me try to find more clamps. I definitely have some clamps. A lot of these are C-clamps, but some of them aren't. And what's going on here? I think this might be fine. Yeah. This doesn't feel like it's bulging anywhere, it just feels like it's not necessarily a super decisive fit, but it seems flat. Let's maybe use this for the alignment step if we can. I mean, I think the alignment requirement is not super strict, so we can get it aligned well enough even without using this. I think that's what I did on the first one I made. I don't know if this is actually together. Feels like there's a bulge wherever the wiring is. Huh. Can't tell if it's just me or if it looks like their pick-in place is kind of wobbling all up and down there. This last couple of LEDs. So that's not a boundary between strips, that's just the LEDs being kind of haphazard on that end of the strip. I think it's together. Yeah. Let's try this then. I guess we need to tape them down to the two sides first. Man, people are hard. Like, I have trouble with angry people and happy people in really different ways. And then, I don't know, I tend to oscillate. I'm kind of angry lately, just generally, but I guess being happy is alright too. I should try that sometimes. With these clamps, it stands up by itself. I complain about the YouTube algorithm a lot, but I mean, partly why I pay attention to it still is that I found a lot of stuff that way. So it's like, it's something I put up with despite it being annoying, but I feel like it still may be useful to complain about it, at least if I think I've got anybody who works at Google following me. I don't know, I still have trouble with big tech companies in a lot of different ways, but especially how it feels like they manage to employ so many people who don't actually agree with what they do. Like, at some point, maybe just stop doing the things that they ask you to do. But, I mean, I don't know. I've got a lot of reasons for being kind of burned out from big company work, but then I've also got people I know who are like doing it for the first time, and it's a completely different experience for them than it was, or than, you know, it's been any time recently for me. Is that Tuco making some noise over there? Alright, let's see if this fits. This needs to be a little closer in. Okay. Seems pretty happy. Let's put some more clamps on. Let's see how many I can put on without having to steal any from the other one. Yeah, great. Not the most even, but... This looks a little bit skew, like it isn't going to fit on here, but it clearly is. I think I should just not worry about it. All right, let's do some glue. I think my biggest problem with the YouTube algorithm is how, because they just completely cater for, view count and clicks and all that, there's this pattern where, if you're looking at videos on some topic, they'll start suggesting you, like, tabloid crackpot responses to that topic. Like, you're looking at, like, science videos, and then it starts suggesting, like, flat earth videos because they have the science keyword in them, that kind of thing. Or, like, just videos that are just, like, the entire purpose of the video is to say, this thing sucks, and then people click on it because they want to know why this thing sucks. And, like, why do they... And then, like, if it was just something that happened, and it was like, okay, I can select for this or not, but it just doesn't seem like there's any way to add relevant training data to say, actually, no, and this is why. It feels like the automated systems that are listening don't have the way to express what I want to express, and it feels like there aren't any humans listening. Give that a little bit of time, and then unwrap this tape, put some glue under the tape. Oh, that glue is still... that glue is still quite liquid. Do you hear somebody counting outside? I think that's related to the gym. There's one of my neighbors is a gym. Not a person named Jim, but a business that is a gym. But it's not like the kind where you go there and then they have a bunch of machines you can use. I think it's the kind where you show up and then they have a personal trainer that goes and beats up a big group of you. I think it's that kind, so I think they do some of their group beat-up exercise outside. Okay, so this just needs some cooling time, just like its friend. And I'm starting to realize I'm pretty hungry. Maybe I should do something about that. This one's feeling pretty cool at this point. We could probably take it apart. How's our bucket of glue doing? So these are hot glue. The other one I used E6000, which is not fully cured, but looks like it would keep the LEDs in place at this point. Let's see how that turned out before I sign off. Let's put that aside. Let's bring back the glass thing. Unplug the glue gun. All right. Still smells like E6000. That looks good. I should probably let it dry the rest of the way before taking the tape off or soldering, but I think I can take the weight off at this point. So we will wire these up probably on the next stream, do some magnet wire, and then we're nearing the point where all these little sub-assemblies that need pre-assembly, like the LEDs and all that, I think we might be about out of those. There's maybe a little bit of work to do on the power distribution bracket, but we're getting close to the point where I can just start actually putting this robot together, which will be fun. So I think that's pretty much it for this time. We've got more of these parts that we're working on, but the actual progress from today's stream consists of putting some LEDs on here and building a couple more of these. And then we have our cable snake. Pretty happy with this thing so far. There's a big mess in this part of the shop at this point. But yeah, nice braided cable snake with a strain relief and all that. So this ought to be pretty nice. This is basically, the robot will consist of this plate, a bunch of stuff below it. This cable will come out the middle, and then the nylon paracord will come out on these 4 directions via this little distribution plate that goes under that. Oh, I just noticed a question from Zalin on YouTube chat who asks, where do you find the black hot glue sticks? They can't find them local. We had a question just like that in the Gitter chat. I'm curious, it might be the same one, but since I'm thinking about it, let's just see if we can look for those glue sticks and see who makes them and where you can find them. I'm curious what these are mostly used for, because I heard about them from Ben Krasnow, who also uses them for like making light-proof seals, basically. Black hot glue sticks. So UXL, which I think they just like resell stuff from eBay onto Amazon. Basically, they have them. Wow, Amazon's Choice has generic ones. Wow. Whoa, there's like a bunch of colors. So these might just be like internet commodity items. I don't know, let's see if you can find them on eBay. Yeah, so, you know, this is pretty much where I've been shopping for them. I'll just get them on Amazon, or I don't think I've gotten any on eBay, but it looks like there's plenty to choose from here too. And yeah, this glue gun I was using was like a $3 hot glue gun. But I've also got a nicer hot glue gun, which is actually worth it. I just don't have one of those in the smaller size that my black hot glue sticks are in right now. Well, I think that's pretty much it for this stream. I'm gonna finish it up with a brief moment of cat here. It is warm over here. Definitely turn on the fan to cool off the servers, if nothing else. Ah. Oh, let's see how the 3D print's doing. I was about to forget on that status. Printer's doing fine. Not as fine as the kitty. Looks like it's printing the vertical sections on the left and infill on the right. Oh, it hasn't even gotten to the horizontal bracket on the right one yet. So it's still printing the motor mount and supports for the whole bracket. Then it's going to print the bracket. Then it'll print the tall pieces. Some gears. I think Duco might want to be left alone. I can't tell because he was feeling a little social, like licking me and stuff, but I think he also might want to sleep. Anyway, thanks for tuning in, folks. We'll have plenty to do on the next stream, more assembly. I also have some other side projects to stream, like this this rework challenge that Andrew Zonenberg sent, and we've also got some small projects that we can do, like there's always bold port kits, and I have some other kind of weird things to take a look at, like maybe this this TENS unit that Dory sent in. So yeah, let me know what you want to see if you have any preferences. Otherwise, I'll keep doing my thing as usual. Thanks for tuning in. And yeah, happy hacking, everyone. Happy whatever day it is over there. We're coming up on Tuesday evening on this side of the world. Happy hacking, folks.